In this module, we're going to be adding a C++ source file created for this course, thereby changing the project from a blueprint-only game to a C++ game. There are a few differences that you may notice with the Unreal Engine interface, but don't worry. It will otherwise act all the same as if it were a blueprint-only project. Before we add the source files, let's convert our project to a code project. In the content browser, right-click and select New C++ Class. A new window will come up asking which class this C++ class should inherit from, just like when we create a new blueprint. This will be an empty class used only for the conversion, so select None and press Next. Keep the name as My Class and press Create Class. Unreal Engine will now tell us it is adding code to the project and compiling it. When it is finished, it will open Visual Studio or your source code editor. This can be set in the engine settings under source code if you need to change this. Navigate to the Oculus OSS folder that was provided with the other files we imported in a previous course, and copy all three of them and paste them inside of our darts folder inside the source folder. And we need to replace the current darts.build.cs file that's already there. Back inside of Visual Studio, in the Solution Explorer, navigate to the source folder and expand darts. Right-click on darts and select Add Existing Item. Navigate to our source folder. Select both the Oculus OSS CPP and the Oculus OSS.h files. This is not a course on working with C++, and we're just going to be setting this up so we can use these already provided files. We do recommend you dedicate time to learning how to program. The time you dedicate to learning programming principles and C++ specifically will immensely improve your ability and reach for creating what is possible. If you've not yet started with C++ but are taking this course as a confident blueprint dev, remember there was a day when you first opened an event graph to create your first blueprint. Look at you now. With these two files imported, we need to tell our build file to look in the locations it wouldn't by default. Recall that we just replaced our darts.build.cs with the same file that was inside of the downloaded Oculus OSS folder. If you were to open that, notice that we've added a couple of additional locations for our solution file to search for, allowing our code to work. If you are interested in adding these yourselves, we added the library OVR platform to the public dependency module names. We added the three locations in our private dependency module names, online subsystem Oculus, and library OVR avatar. We aren't going to be using the avatar in our course, but we are including it here because the source files take advantage of it for future use. And then we added this if statement towards the bottom, that if we're running this on Windows 32 or Windows 64, to include a specific DLL file. Okay, let's close Visual Studio. Press Save. Return to the project inside of Windows Explorer, right-click on the U project file, and select Generate Visual Studio Files. Then reopen the .sln solution file. And then I'll reopen Visual Studio. And now Visual Studio has all the assets it needs to run a successful build. So at the top, select Build, and click Build Solution. And when this finishes, go ahead and close Visual Studio as well as Unreal Engine, so they could both update. Reopen Unreal Engine. In the content browser, expand the left sources panel. You should now see that there is a C++ classes folder. Open it, and inside is a darts folder containing our Oculus OSS file. Now we can create a blueprint for us to use that inherits from this C++ class. Inside of our core folder, right-click and create a new blueprint class. Under All Classes, search for Oculus OSS. Select it and press Select. Name this BP Oculus OSS and open it. Right-click in the event graph and search for Rich Presence. Here are all the functions available to us regarding rich presence in this blueprint. Okay, before we end this module, let's add a new function to our BPI darts com. Create a new function named setRichPresence with a bool input named isJoinable. I'm going to place this into the category rich presence. and I'll compile this. Back in our new BP Oculus OSS, implement the interface BPI darts com and compile it. Remember back in the Oculus dashboard at our destinations. When a user wanted to travel to this destination from outside of the game, our destination was going to send a deep link message. This message was command::load_darts_map. We're going to receive this message from an event that our source file will be waiting for. Right-click the event graph and search for Event on Received Deep Link Message BP. The value that comes out of DL message is whatever we had written after the command::. You can use this data to change how your game reacts to a player coming in through destinations. From DL message, create a switch on string and add 2 new pins. The top one should say load_darts_map. The second can be something more relevant to your project. Perhaps your game has a special item that is given to players who arrive this way. I'll write user likes pizza. Now, if they arrive from a destination that sends this command, I can use this to make sure that the player receives extra points for honesty. Okay, where I am getting at, of course, is that the game can change however you need it to. More practically, a destination wouldn't be the start of your game, though it could be. You'd want your project and the pawn they possess, and whatever items they are holding, to be ready for them when they arrive. In the final module of this course, we'll finish setting up the destination, talk about rich presents, and test this all out.